I want to talk now about some situations where we have constant velocities. Now, I'm not going to quite call this uniform motion because it's a little more complicated than that, but this is still helpful in that we can think about what's happening in terms of velocity and acceleration and simplifying our situation. So in this first situation, each piece is uniform motion, and the idea of uniform motion is that we in fact have a straight line in position. Now note that this is a plot of position, you see so on your y-axis, and if we just look at this, it's piecewise, that there's these breaking points, but in between these breaking points you have a straight line. So we have a constant slope here, then we have a constant slope here, and then in this third piece we again have a constant slope. So now later we will do a similar analysis when we are talking about instantaneous velocity, but here we could just think even about average velocity, that if we start at time equals 0, x equals 0, that we're ending up 2 seconds later at x equals -4 meters. So we could actually calculate a velocity from that. And we know that it's going to be negative, which in this case means moving to the left if it's an x coordinate, and because we've gone from 0 to a negative value. So if I then look at a plot of the corresponding velocity, we see that we have a constant velocity over those first 2 seconds, and that constant value is equal to -2 meters per second. And again, we could just get that by saying that I've gone, what's my delta position? My final position is -4 meters, my initial position was 0, and my change in time, my time interval, was 2 seconds. That gives me -2 meters per second, which is what I see there. Now during this part of time, our object has been still. It's not moving. So there, your velocity is 0. Now after this, we then start from this position and go here. Now something to be a little bit careful about is that to actually say what this velocity is, you need to say now that you have your final position minus initial. Final was 6 meters, subtracting our initial position, which was -4 meters. And that occurred over, again, 2 seconds. And so 6 minus -4 is 10 meters over 2 seconds, which is just going to give you 5 meters per second. So please be careful and not just use the coordinate value, but really remember that you're looking at your rise, your change in your position, which here was actually 10 meters, over the time that that took, which in this case was 2 seconds. So we use the slope, and in this case we again see that these are straight lines, so we have uniform motion in each segment, so constant velocities in each segment. We go from a plot of position to a plot of velocity. So again, you can think of this as taking a derivative. We had a constant slope here, constant slope here, constant slope there. There are a few more things I want to point out here. One is that the fact that this is a negative on the x position means that normally if we have motion, we're going to define x to be the horizontal direction, and we've just defined some value of x equals 0. So our object started at x equals 0 and actually traveled to the left initially, and that corresponds to that negative velocity. So this negative is because it's traveling to the left, getting more negative. It isn't negative because the position itself is negative. The second thing to notice is that if we just look at the value, absolute value of the slope, not the sign, that this is steeper. A bigger change happens over the same amount of time compared to this first segment. And that's why this is 5, while this was 2. So the sign comes from the fact that your slope is negative. Here it's positive, so you have a negative velocity here and a positive velocity here. This is moving to the left, this is moving to the right. So please be careful about the difference between just your position being negative versus your slope or your velocity being negative. And keep in mind that a greater value of slope, again 5 compared to 2, that's telling you effectively your speed. So your speed here is 5 meters per second, your speed here is 2 meters per second. So this is moving slower, but it's moving to the left. This is moving faster, and it's moving to the right. So if you have access to the book, this is Tactics Box 2.1, but briefly in words, this just says some of the things that I went through in the past slide, that steeper slopes are faster speeds, and steeper can be either in the positive or the negative direction. And negative slopes are your negative velocities, so that would be motion to your left or motion down for our normal coordinates, and that we need to be careful to make sure that you're always using these intervals. So the change in position and the change in time, not just the coordinates. So again, look at what your initial and your final positions are, your initial and final time, not only the final ones. If you just plug in your final position and your final time and you didn't start from the origin, you're going to get the wrong value. So that's very important.